Welcome back. We are now at chapter 15.3, textbook 254, conservation of linear momentum for a system of particles. Yeah. So when a sum of external impulse acting on the system of object is zero, the linear impulse momentum equation simplifies to this. Okay. I think you have seen this formula, yeah, back in your school. You remember MA VA plus MB VB initial. So you put the 1 here equals to MA VA final plus with MB VB final. Yeah, so this is this formula. So this formula, yeah, is a combination of all the object that is in the collision. So if let's say it is A object, just redraw this thing. So you have object A and object B moving. So after that it collides. Let's say it just cling up together. A and B move together. So this formula, this one, because it's a conservation of linear momentum, it will be actually discussing both A and B. Whereas the formula earlier, remember this one? Yeah. So if let's say you have object A and B, if let's say you have object A and B, okay, and then it's moving together, example. So this formula, if you discuss about A, so it's all about A. It's all about forces of A only. So this A means A, B means B. Yeah. So there is no combination. So if let's say I were to write this back, so it will be A initial plus with all the forces that is on A dt equals to A final. Yeah. So there is no combination. Whereas this formula, it's a combination. Yeah, it's a combination like what I've just written here. Okay, so that is the difference. So some questions may ask you for combination. Some questions may just ask you by the object. So you have to read carefully and you choose which formula to use wisely. Yeah. Okay, so coming back to this equation is referred to conservation of linear momentum like what I've given you. So when particles impact, only impulsive forces cause a change to the linear momentum. So this is an example of a sledgehammer. Yeah. Okay, so there are examples on the slides itself, like what I've told you. I always go through tougher example from the textbook. Slides 1, you can just read it by yourself. Yeah. Okay, so let's do example 15.4. Okay, let's look at example 15.4. It's a very good example because it shows both the usage of both the formulas. Yeah. Okay, so a 15 megagram box A is coasting at 1.5 meter per second on the horizontal track when it encounters a 12 megagram tank car B coasting at 0.75 towards it. So you're having a collision here. Yeah. So if the car collides and couple together, so they couple together at the end of the day. Yeah. So what we have here, determine A, the speed of both cars just after coupling. B, the average forces between the coupling which takes place in 0.8 second. So that's what we are going to calculate. Yeah. Okay. Let me just erase this because it looks so you can see it clearly. Okay, let's solve this question. The first thing they want the speed of both cars, yeah, of coupling. Okay, you can actually, first step is always to draw the free body diagram. Yeah, like example this one, this is a free body diagram and the motion diagram. Can you see that? That's the kinetics. This is the free body diagram. So from this diagram, what we know is that MA, which is 15,000, multiply by 1.5, okay, minus. Why is it minus? Look at the diagram again. This is coasting towards it. It means it's coming from the opposite side. Can you see? So that's why the diagram is very important. Yeah, that's why you're generating a negative here. 12,000 multiplied with 0.75, and final velocity, will be a combination because it couples together. So 27,000 kilogram. How do you get 27? 15 plus 12,000. Yeah, multiply with V2. So V2 is 0.5. So if you get a positive value, which means the direction will be towards your right. Yeah, okay, that's done with part A. Part B, they're actually asking you to calculate the average force between them if the coupling takes place with 0.8. So average force between them. So you need to pick one of the object. If you want to do A, then it is like the textbook. Now you can repeat your by yourself at home with formula for B. Okay, so let's do A first. This formula, remember the formula with all the forces that's in between and the movement. So we have 15,000 multiplied with 1.5 and average force, yeah, multiply with 0.8, because this is the one that they are actually they want you to calculate. And 15,000 multiplied with 0.5. Where did you get the 0.5 from the previous calculation? Yeah, so your average force will be 18.8. Try solving this, yeah, for object B by yourself. Yeah, so what do you have here? Object B, 12,000. You put 12,000 here, and then you put the velocity of B, you put B's weight and the 0.5, yeah, and then 0.8 here, and you will get you should get the same average force. Yeah, so now I'm done with this particular subchapter. I'll meet you in the next subchapter. Thank you.